Meet the F-35 Lightning II, the world's most advanced fighter jet, capable of supersonic speeds, radar evasion, and even vertical landings. But the real powerhouse behind this high-tech marvel? The F-135 engine by Pratt & Whitney, a beast delivering over 40,000 pounds of thrust. Today, we're taking you inside Pratt & Whitney's Middletown facility to see how engineers and technicians craft the most sophisticated fighter jet engine ever built. From cutting-edge assembly lines to jaw-dropping engine tests, you're about to witness precision, innovation, and sheer engineering brilliance like never before. All right, folks, buckle up because we're about to take a virtual ride through one of the coolest spots in American aviation history. I'm talking about Pratt & Whitney's F-135 engine facility right here in Middletown, Connecticut. This place is where the magic happens for the F-35 Lightning II, that fifth-generation fighter jet that's redefining air power for the U.S. military and our allies. If you've ever wondered what it takes to crank out an engine that pushes 40,000 pounds of thrust, enough to make your average car look like a toy, stick around. We're gonna break it all down, from the nuts and bolts of assembly to the high-tech testing that ensures these bad boys are ready for action. First off, let's set the scene with a bit of backstory on this sprawling campus. Back in the 1950s, this wasn't just any industrial park. It was a hush-hush government site for testing nuclear propulsion tech. Yeah, we're talking Cold War-era secrets, where engineers were pushing boundaries on power sources that could change the game. Fast forward to 1969 when the feds wrapped up their project, and Pratt & Whitney swooped in. They transformed it into a hub for cranking out top-tier aircraft engines. And man, have they delivered. For all you aviation buffs out there, av geeks, as we call them, this facility has churned out power plants for icons like the F-15 Eagle, the F-16 Fighting Falcon, the massive C-17 Globemaster, the stealthy F-22 Raptor, and now the F-35. But it's not all military muscle. They've also powered civilian giants such as the Boeing 707, the Queen of the Skies 747, the reliable 777, and even Airbus models like the A310, A320, and A330. It's like this place is the beating heart of modern flight, blending defense tech with everyday air travel. Today, though, our spotlight is laser-focused on the F-135, the engine that makes the F-35 tick. This thing is a beast, packing more punch than any other fighter jet engine in service right now. To really get the lowdown on how it all comes together, I linked up with the head engineer, Brent, who's basically a walking encyclopedia on this stuff. We kicked things off with a tour of the massive setup. Picture this: over 2 million square feet of space on 1,200 acres, with around 2,400 folks working here. About 1,400 are hands-on production pros, and another 1,000 are the brainiac engineers dreaming up the next big thing. Beyond the assembly floors, they've got manufacturing zones and these hardcore test cells where they put every engine through its paces on military-grade setups. Brent and I dove right into the action with a walk and talk along the F-135 assembly line. It all starts with sourcing parts from around the globe. Over a dozen countries pitch in, like Poland, Italy, and France. Everything converges here in Middletown, where teams kit 'em up and piece it all together on this high-tech line. The heartbeat of the operation? That'd be the high-pressure compressor, or HPC. It's the core where all the energy kicks off, feeding into the combustor and setting the stage for the rest of the build. From there, they stack the rotors with insane precision. We're talking tolerances tighter than half the width of a human hair. Mess that up, and you're back to square one. How do they nail it? A killer combo of smart machinery, clever engineering tricks, and skilled workers who know their stuff inside out. Moving down the line, we hit core assembly, where the engine really starts looking like an engine. The F-135 is built in modules, which is a game-changer for maintenance and upgrades. Swap out a section without tearing the whole thing apart. Smart, right? And get this, the F-135 didn't come out of nowhere. It evolved from the F-119, the engine behind the F-22 Raptor, which is hands down one of the most badass birds in the sky. Lessons from the F-119? Tons. It laid the groundwork for reliability and performance, letting the F-135 build on that foundation while stepping up to single-engine safety for the Joint Strike Fighter program. Going from twin engines to one meant cramming in more thrust and power without skimping on dependability. It's like upgrading from a muscle car to a supercar. Now, not all F-135s are created equal, because the F-35 comes in 3 flavors: the A variant for straight-up air dominance, the C for those nail-biting carrier ops, and the B, which pulls off short takeoffs and vertical landings like it's no big deal. That B model uses the STOVL version, short takeoff, vertical landing. It lets Marines and our partners launch from tiny airstrips or compact carriers that bigger jets couldn't touch. In STOVL mode, half the thrust blasts from a lift fan up front, and the other half swivels out the back nozzle. Visually, it's mostly the same as the conventional takeoff and landing, STOVL version, but with some weight-saving tweaks. Think lighter composite ducts instead of heavy metal, plus bypass air scoops for roll control jets that keep the plane steady mid-hover. The star of the show? That 3-bearing swivel module. It tilts down to 45 degrees for short takeoffs, or a full 90 for straight-up landings. It's engineering poetry in motion. As we wrapped up the vertical build phase, the engine flips horizontal for final touches. Quality checks are non-stop, but they're dialed up here to catch any glitches. Foreign object debris, FOD, is the big bad wolf. Even a stray pen or bolt could wreak havoc in the airflow path. Pratt's got a full-on FOD prevention playbook, training sessions, strict rules, and everyone on the floor keeping things spotless. It's like a zero-tolerance zone for clutter. One of the slickest parts of the process is their smart kitting system. Parts get prepped and delivered right to the mechanics in ergonomic setups. Everything labeled, easy to grab, no fumbling around. Finish one job and the next kit rolls in automatically. Then there's the smart torque tools. These gadgets ensure every nut and bolt gets tightened just right, per the build specs. It's a huge win for quality, cutting down on errors and making sure the externals are rock solid. I even got to try one out. Feels like holding the future in your hands. Chatting with Brent, I had to ask, what's it take to land a gig here? Pratt & Whitney is part of RTX, a giant with over 180,000 employees worldwide, so opportunities abound. But the key? They're after sharp-driven folks passionate about aerospace. Whether you're wrenching on hardware or crunching designs, if planes get your blood pumping, this could be your spot. Stealth is a huge deal for the F-35, slipping past radar like a ghost. Naturally, the engine plays into that. Brent couldn't spill all the classified beans, but yeah, the F-135 was designed with the same low observable requirements as the jet itself. It's what separates 5th-gen fighters from older birds like the F-15 or F-16. Since the first F-135 rolled out in 2006, they've poured in upgrades, tweaking the design and streamlining the line. Military engines mature over time, moving from early configs to full production beasts, often via modular swaps. Looking ahead, that modularity sets up for even bigger leaps. In the final assembly zone, all modules unite, and the last externals get bolted on. The setup is wild. Engines hang upside down on rotating rails, letting mechanics work comfortably at any angle. Once it's in the F-35, communication is key. That's where the FADEC comes in. Full authority digital engine control. It's the brain that lets the engine run itself and chat with the plane's systems seamlessly. None of this happens without the team. Thousands of mechanics, engineers and supply pros grinding daily. After assembly sign-off, engines head to the test cells in Building 410. Each one runs for hours under brutal conditions, mimicking real-world stress to confirm it's flawless before shipping. In the test bay, they hoist the engine via overhead rails and lock it into a thrust stand. A big metal cone, the fault screen, blocks any debris from sneaking in. They measure everything: airflow, thrust, vibes, temps, fuel burn, all against strict specs. Back at the nozzle end, exhaust tunnels stretch over 50 feet to handle the inferno safely. It's loud, it's intense. You feel the rumble even in the control room. Speaking of which, the control room is mission central, with screens tracking every metric. I got to play pilot for a sec, grabbing the throttle for a vibe survey. slow ramp from idle to full power, hold, then back down. Monitors check vibrations to ensure smoothness. Then the thrust transient, snap from 10% to 150% thrust, like slamming afterburners for takeoff. 40,000 pounds of force roaring out. It's visceral, the nozzle flaring wide. The engine responds lightning fast, proving it's combat ready. I even ran a couple myself. Slow accel first, then a quick snap. Felt like channeling Maverick from Top Gun, but with real stakes. Finally, post-test, it's off to the pack line. Engines get boxed up neatly on trailers, ready for their F-35 destiny. But what's next for the F-135? The buzz is all about the engine core upgrade, ECU. It's a revamp of the core to pump out more electrical power and cooling. As the F-35 piles on advanced weapons and systems, this keeps it ahead of the curve. Pilots need Block 4 capabilities ASAP, next-gen munitions that demand extra juice. The ECU delivers, rolling out fast to equip warfighters. And it's not just Uncle Sam. This upgrade is trivariant, fitting all models, A, B, and C, and going global to partners. It's a unified boost for everyone flying the flag. Wrapping up, touring Pratt & Whitney was eye-opening. The precision, the innovation, the sheer scale. It's American ingenuity at its finest, powering the jets that protect our freedoms. If you're into tech, defense, or just cool machines, this is the stuff that inspires. Thanks for tagging along. Hope it fired you up as much as it did me. Catch you on the next adventure.